Let's understand the difference between RAG and fine-tuning. Let's compare RAG versus fine-tuning across different dimensions. The first one is in terms of what gets changed. RAG adds external data at the time of the query, whereas fine-tuning modifies the model itself by updating its internal weights. And let's understand where each works best. RAG is ideal for latest, private, or frequently changing information, whereas fine-tuning is best for controlling tone, format, and domain-specific behavior. And in terms of how easy is it to update, RAG is quick and low cost, just update or re-index documents, whereas fine-tuning is time-consuming and expensive. It requires retraining, and when it comes to accuracy of factual answers, RAG is more accurate if the retrieval step is strong, whereas fine-tuning is limited to what the model learned during training. And when it comes to transparency or auditability, RAG can provide sources and citations, whereas with fine-tuning, knowledge is hidden inside the model. So the takeaway is RAG keeps your knowledge fresh and traceable, whereas fine-tuning shapes how the model behaves. So use each where it fits best in your project. Okay, let's learn the common failure modes of RAG systems in production. Some of the common failures are outdated or stale data. That is, when the index isn't updated, then the system returns old or incorrect information. And the other common failure is poor chunking. If chunks are too big, then it leads to too much noise. And if chunks are too small, then we may miss context. And the next common failure is missing metadata filters. That is, retrieval pulls irrelevant data because it's not properly filtered. For example, the wrong product, time, or user, etc. And the other common failure is embedding drift. That is, after updating embedding models, old and new vectors don't align well, which can hurt retrieval quality. And the next common failure is too large top K. That is, retrieving too many chunks can add noise and can pollute the prompt. And another common failure is re-ranker latency spikes. That is, re-ranking improves quality but can slow down the system unexpectedly. Next one is prompt injection from documents. That is, malicious or misleading content inside documents can influence the model's output. And one more, citation laundering. That is, the system shows citations, but they don't actually support the claims made. So the takeaway is RAG failures usually come from bad data, poor retrieval tuning, or weak guardrails. So monitor and fix each layer carefully. Okay, let's see how to balance recall versus precision at scale in RAG. First, start with high recall, that is broad search. That is, in the first step, retrieve a wider set of results to make sure you don't miss important information, and then improve precision with re-ranking. That is, in the second step, use a re-ranker to filter and reorder results so only the most relevant ones remain. And then use thresholds and adaptive top K, that is, apply similarity score cutoffs to remove weak matches. Also, use a smaller top K when confidence is high and larger when it's low. And also, segment your data. That is, split indexes by domain. For example, product, team, region, etc. to reduce unnecessary search space. Also, apply metadata filters. That is, narrow down results using filters like date, category, or user context. So, the takeaway is first retrieve broadly to avoid missing answers, then narrow down aggressively to keep only the most relevant information. Okay, let's understand what is a multi-stage retrieval strategy in RAG. Let's understand the step-by-step process. In stage 1, broad retrieval, that means fast and cheap. So use methods like BM25 or keyword plus vector search, and the goal is quickly gather a wide set of candidate results. And in stage 2, re-ranking, that means more accurate. So use a cross-encoder model to reorder results and push the most relevant information to the top. And in stage 3, refine the final context. So select diverse and useful passages, for example using MMR, and compress or summarize to remove unnecessary content. Okay, now let's understand why this approach works. First one is better relevance. That is, you are first casting a wide net and then carefully filter the best results. Also, less prompt overload. That is, only the most important information is passed to the model and you get more accurate answers. That is, higher quality context leads to better responses. Also, fewer hallucinations. That is, the model relies on strong, relevant evidence. So, the takeaway is multi-stage retrieval balances speed and accuracy. So, start broad, then refine to deliver the best possible context to the model. Let's learn how to design RAG systems for real-time or frequently changing data. We have few ways to achieve this. The first one is use connectors to live data sources. That is, connect directly to databases, APIs, or systems where data is constantly updated. And the other one is incremental indexing or update only what changed. That is, instead of rebuilding everything, update only the documents that have changed. The next one is use short cache lifetimes. That is, keep cache durations small so the system doesn't serve outdated information. Okay. The other one is event-driven updates. That is, trigger updates automatically when data changes. For example, when a new record is created or a file gets updated, etc. And also add timestamps in metadata. This helps prioritize the most recent and relevant information during retrieval. The other one is use live queries for real-time facts. That is, for highly dynamic data, directly query a database or API instead of relying only on embeddings. So the takeaway is, for real-time RAG, keep data fresh with smart updates and use live sources when accuracy matters most. Okay? Let's understand what privacy and security risks exist in enterprise RAG systems. Some of the risks could be sensitive data leakage. That is, the system may retrieve and show documents to the wrong user. Another risk could be prompt injection attacks. That is, malicious content inside documents can try to manipulate the model's behavior. Okay. Other risk could be data exfiltration through outputs. That is, the model might unintentionally reveal confidential information in its responses. The other one, logging sensitive data. That is, storing user queries or retrieved context can expose private information if not handled properly. Okay. Next one is embedding risks. That is, in some cases, embeddings can be reverse engineered to expose original data, which is nothing but embedding inversion. Now let's understand how to reduce these risks. First one is access control during retrieval. That is, ensure users can only access documents they're allowed to see. Next best practice is content sanitization. That is, clean and validate data before using it in prompts. Okay. The other best practice to avoid risk is sandboxing. That is, isolate risky operations to prevent system-wide impact. The other one is redaction. That is, remove or mask sensitive information before sending it to the model. Next one is strict logging policies. That is, limit and secure what gets logged to protect user data. So the takeaway is secure RAG systems by controlling access, cleaning inputs, and preventing sensitive data from leaking at every step. Okay. Let's understand how do you handle long documents that exceed model limits. Try not sending the whole document because LLMs have context limits. So passing everything will overwhelm the model. Okay. And use hierarchical retrieval. That is, first find the relevant section and then retrieve the specific passage inside it. Also, chunk the document smartly. That is, break the document into smaller pieces with slight overlap. So we can keep the context connected while staying within limits. Okay. Next one is use summarization. That is, summarize smaller parts first and then combine them into a final summary. Also, apply context compression. That is, extract only the most relevant lines or spans and remove unnecessary text. Okay. The next one is leverage document structure. That is, use headers, sections, and IDs. This will help retrieve meaningful and complete chunks. So the takeaway is, for long documents, retrieve and compress only what matters and don't overload the model with unnecessary text. Okay. Let's learn how do you monitor and debug RAG systems after deployment. First, let's understand what to log for. First one is user query and rewritten query. That is, check to see how the system interprets user input. Also, check retrieved chunks with scores. That is, track which documents were fetched and how relevant they were. And look for final prompt size. That is, monitor how much context is being sent to the model. Okay. Also, check citations used. That is, check which sources the model relied on and latency at each step. That is, measure time taken for retrieval, re-ranking, and generation. And check user feedback too. That is, capture ratings or corrections to improve the system. Also, try building dashboards for insights. Dashboard can include retrieval quality signals. That is, similarity score distributions. Check for which results are actually used. That is, check for clicks or citations. Okay. Another one to include in dashboard is system performance trends. That is, spot issues like slowdowns or drop in quality over time. and also run regular evaluations. Evaluations include benchmark dataset, that is, test on a fixed set of questions to track consistency. Also, evaluate real user queries, that is, sample actual usage to catch real world issues. So the takeaway is monitor every step, measure performance, and continuously test. And strong visibility is the key to improving RAG systems in production. Okay? Let's understand how do you improve grounding and citation reliability in RAG. First thing is you can try highlighting the exact supporting text, that is, extract the exact sentences that support the answer. This makes it clear where the information comes from. Okay? And other reliable one is force citations in answers. That is, design prompts. So every claim must include a source. This will prevent unsupported statements. And add answer verification step. That is, use another LLM to double check if each sentence is backed by the retrieved context. Next one is detect any contradictions. That is, identify when sources disagree and handle it properly instead of ignoring it. And align citations with actual text. That is, ensure if citations truly support the specific claims they are attached to. And use precise references like chunk IDs, offsets. That is, point to exact sections instead of entire documents. This can improve trust and traceability. So the takeaway is strong RAG systems don't just cite sources. They prove every claim with precise, verifiable evidence. Okay? Let's understand how does multilingual data affect RAG retrieval and embeddings. We have few options here. First one is use multilingual embeddings or separate indexes. That is, choose embeddings that understand multiple languages or create separate indexes for each language. Okay? The other option is detect the query language. That is, identify which language the user is using before retrieval. This will help route the query correctly, right? The other one is use translation when needed. That is, translate the query to match the data language or translate results back to the user's language. Also, be careful with translations because sometimes the meaning can change during translation and this can weaken accuracy and citations. Okay? Also, try using language metadata, that is, tag documents with their language. This helps filter and retrieve the right content. So, the takeaway is multilingual RAG needs smart embeddings, language detection, and careful translation to keep meaning and accuracy intact. Okay? Let's understand how is Agentic RAG different from classical single pass RAG. Let's understand the difference in multiple aspects. First one is in terms of control flow. Classical RAG has a fixed pipeline, that is, first retrieve and then generate, whereas Agentic RAG has an iterative loop, that is, plan, then retrieve, then refine, and then repeat. And the next one is in terms of retrievals. Classical RAG has one-time retrieval, whereas Agentic RAG can have multiple retrievals as needed. Okay? And the next one is in terms of query handling. Classical RAG uses the original query, whereas Agentic RAG can rewrite and break down queries dynamically. The next one is in terms of model's role. Classical RAG just generates the answer, whereas Agentic RAG acts as planner, researcher, and writer. Okay? And in terms of reliability, classical RAG depends on first retrieval, whereas Agentic RAG improves by gathering more evidence over time. Okay? Now let's understand the key differences. In terms of single pass versus multi-step, classical RAG is a one-shot process, whereas Agentic RAG works in multiple steps. And in terms of static versus dynamic behavior, Agentic systems can adjust, refine, and explore based on what they find. Okay? And in terms of more control versus more flexibility, classical RAG is predictable, whereas Agentic RAG is more flexible but complex. So the takeaway is classical RAG answers once, while Agentic RAG thinks, searches, and improves step by step for better results. Okay? Let's understand what trade-offs does Agentic RAG introduce. First, let's see in terms of costs and downsides. Agentic RAG can introduce higher cost, that is, more steps equals more tool calls and model usage, and this can increase the overall compute cost. Okay. The next one is Agentic RAG can add higher latency or slower responses, that is, multiple iterations can take more time, and this is not ideal for real-time use cases. And the other one could be less predictability, that is, the system can take different paths each time and it can be hard to control and debug. Okay, now let's see how can we manage it. We can manage by adding guardrails, that is, limit max steps, set tool usage budgets, and define clear stopping conditions. also add stronger monitoring. That way you can track behavior, cost, and performance closely. Okay, so what do we gain with this? We can handle complex problems better. That is, you can break down questions, pull information from multiple sources, and also improve answers step by step. Okay, so the takeaway is Agentic RAG trades speed and control for deeper reasoning. So Agentic RAG is more powerful but requires careful management. Okay,